Welcome back to Math's Playground. Today we will be doing angle-angle similarity. But first, before we start any problems, what is similarity? Well, you call two figures similar if one is simply a blown up, rotated, or flipped around version of the other. So that makes all of the angles that are on the inside the same. So, we're going to start with a pretty simple problem. Below are two triangles that have the same measure for two angles. Find the third angle in each and find the side ratio. Okay. So, we can just take random numbers since we don't know the sides. So first, let's find which way they're similar, and depending on that, we'll do the sides. We can find the side. We can do random sides, see if they work, and blah blah blah. So so notice how ABC it is just uh is just a flipped over version of DEF, and it's a little smaller. So since we don't know the sides, let's not do the side ratio part. So, so let's continue. Okay. So we know that these two are similar, right? So if we find one angle, so we know the inner angles of a triangle add up to 180. So 50 and 60 make 110, which means we know the other angle will be 70. And EFG will be the same because 50 plus 60 is 110. But um but also because if you flip ABC over, the 70 would be right up here. Okay, so if we take random sides, 3, 6, 4, 8, 5, 10. Okay, then the side ratio. Let's take AB by DF. AB divided by DF would be 3 over 6, which is 1 by 2. So this is how you find side ratios. Oh, and if two figures are similar, you're sure that the side ratio for all three sides are the same. Because if we take AC divided by ED, that would be 4 by 8, which is also 1 by 2. And then if you take CB divided by EF, that is equal to 5 by 10, which is 1 by 2. And side ratios only work if you take the corresponding sides. So if we flip this over to make the angles position same, then AC would be at DE, and AB would be at DF, and BC would be at EF. Okay, let's go into a little trickier problem. So in the figure at right, MN is parallel to OP. OP is equal to 12, MO is equal to 10 and LM is equal to 5. Find MN. Okay, so we've got to find this. Okay, so let's start by finding the side ratios. So since we know LM and LO, let's use that. We know that LM divided by LO would be whatever the side ratio is. So we know LM is 5. LO must be 5 plus 10, which is 15. So that is 1 by 3. Sorry, not 13. It's 1 by 3. So now let's use this side ratio to find MN. So I know this because M and L is just the shrunk up version of BOL because we have the single which is in common. Then since OP and MN are parallel, we know that this angle and this angle also must be the same as this angle and this angle. So this does work as angle-angle similarity. Okay, so back to this. We would then have MN divided by OP is equal to 1 by 3. So MN, which is the one we don't know, divided by 12 is equal to 1 by 3. Now if we cross multiply, we get 3MN is equal to 12, which means MN is equal to 4. Side ratios might be hard to find, but they are super helpful. Okay, last problem of the day. So the lengths in the diagram are marked, and WX is parallel to YZ. Find BY and WX. Then we need to find this and this. So if we know that WX is parallel to YZ, we immediately know that this angle is the same as this angle and this angle is the same as this angle, which makes WX a shrunk up rotated version of BY, which makes WXB a shrunk up rotated version of BYZ. Okay, which means we can use the power of side ratios yet again. So since we know WP and PZ, we can use that to find the side ratio. So WP divided by PZ is equal to 5 by 10, which is 1 by 2. So now we can use this side ratio to find WX and BY. So if we start with WX, then WX divided by, if you flip this over, then you would get YZ is the corresponding side to WX. So WX divided by YZ is equal to WX divided by 12. So we know that WX divided by 12 is equal to 1 by 2. So now let's cross multiply again. So we know that 2WX is equal to 12. So then WX is equal to 6. Now let's do the same for BY. So the corresponding side to BY would be XB. So then XB divided by by is also 3 divided by by. So now we know that this is equal to 1 by 2. Let's cross multiply again, and we end up with by is also equal to 6. So x and by are both equal to 6. Okay, that's it for angle-angle similarity, but we have more types coming up. See you next time!